Today is 27th of October 2023, and I'd like to introduce you to the topic Loci or locus. Okay, it's a simple topic, we know it already, but at times a question might come on it in discuss, so I want to share that with you today. Now, thank you to everyone who have been watching our videos, who have subscribed, who have shared. There are a few comments. I appreciate that a lot. Okay, please, if you haven't already, subscribe, share, like, and follow. Okay, I'll really appreciate that. Thank you so much. I normally write, please follow my notes/script in the comment section, and I think it's a good habit to follow the notes and the scripts. Okay, I'm not perfect, I can make mistakes, but because I go through the notes over and over again, I hope there is not much mistakes. Maybe as I'm going through the notes and I'm sharing with you, I may make a few errors, maybe rectangle, I'll say triangle, or triangle, I'll say rectangle, or at times percentage, those stuff. Okay, but if you follow the notes, then everything on the notes is what you should go by. Okay, so if for instance this is 1 centimeter radius, okay, and you hear 1 meter, follow the note is 1 centimeter, please. Okay, and then under this last video and the last 2 questions, because we're talking about bearings and we've done like 5 bearing videos, I wanted to throw in as much question as possible, to show you that they can ask the question in so many ways and the wording. So I realized that the last 2 examples, the diagram was a bit cluttered. Okay, so what I'm going to do is I'm going to leave bearing for now and do other things with you, but with time, okay, I will use the starter sessions segments, and then I will bring back maybe similar questions of what I did, but not a lot of questions. So I might bring a diagram like that on bearing, and then maybe I'll do like 2 questions, okay, just to remind you what we've learned on bearing. Okay, because I realized that those doing the higher paper might be able to understand the diagram, okay, with all the circles and the things I did. But maybe if you are doing foundation work and you saw that, or maybe that was the first day you were watching the video, it might just put you off. Okay, so please don't be put off. I will go back and use some of these starter sessions. Bring those questions. Maybe we'll look at one or two in there, because we don't really have a lot of time for this starter session. So I'll bring one or two of those questions, and then we will answer them so that you can see what I'm trying to show you. Okay. Beware of scammers. Okay, please, they are everywhere. Beware of them. Don't fall for people asking for donation and money and stuff. Don't fall for it. I haven't done that. If I have anything to say to you, I will say it to you as I'm saying it now. Okay, I wouldn't go behind the curtain and be asking for donations. I do not do that. It's not coming from me, please. Thank you very much. Now, recap. As I said, we did more bearing examples. Okay, I've done 5 videos on bearing. Okay, so by now, if you don't even understand the first 2 or 3 videos, should be able to help you, because all you need to do in bearing is understand that the basic, and then use your knowledge and angle and solve most of the questions. Okay, so as I said in the beginning, I will come back. We'll use some starter questions from time to time. We will bring a diagram. Maybe we'll only look at 2 questions at a time, so that by the time you are ready for your exams, you'll be able, I will make the diagram that cluttered and solve a lot of questions. Okay, and you'll be able to be confident to answer these questions. Okay, but refer to all the various videos. Okay, it will help you a lot. Now today our starter will practice using the compass. Okay, this is a compass, that one. Okay, don't go to maths without your mathematical set, and that is a protractor. Okay, that is a protractor. Okay, and that is a ruler here. Okay, I've always done that. Okay, do not ever use it as a habit. If you have maths, try and go to one of the shops or look online. You might get a bargain on a mathematical set. Okay, I've had these things very, very long time, and I still use them. Okay, if I have to show, if maybe somebody asks me what I think about this and have to explain, I do use them. Okay, at home with my kids, and I also like I'm doing now. Okay, so please, it's a good habit to have those. I've always had that. Okay, not because I like maths, but because from school I've always been told never come to maths without your mathematical set. It's like going to a work without your tools. Okay, this platform is very wide. It's for young adults, for people who are doing Gcse. So I assume most of you have jobs or you have part-time work. So that's what times I give you real life examples. Okay. Now we want to practice using our compass, which I've just shown you. So draw a radius of 1 centimeter. So what I did was I used this compass, okay, open it up, okay, and then measured it on the ruler, and then I drew my circle. So if you can see 1 centimeter here, okay, today we'll try and see if, let's zoom in, okay, there, 0 to 1, as you can see, there, okay. So I measured 1 centimeter using the compass, and then I drew the circle, okay. The next one is draw a circle of 1.5 centimeters. So that is my circle. Again, I use the compass and the ruler, okay. That is 1.5 centimeters. So as you can see, let's zoom in and see. Okay. There, that is the 0, and that is 1.5. Draw a circle of radius 3 centimeters. So again, that is my circle. 3 centimeters again. Okay. Yeah. So you can see that, like this diagram, 1 centimeter, 1.5, 3 centimeters. So if somebody is in a foundation class, if you do something like this, they are happy. But yesterday I realized that because I was trying to finish, I didn't want to do another video on bearings. I was trying to just answer as many questions I can, which is my fault. So the last 2 examples, I had used it and circled a lot of things that I did. Okay, so what I'll do is I'll use this starter session, and with some of the upcoming videos, I'm going to bring similar questions on bearings, and then we will just use the diagram to solve maybe 2 questions at a time. So maybe what is the actual distance from this point to this point? We will measure it. What is the bearing of R from T? We would do that. What is the bearing of S from T? Because after all the videos I've done, now you should understand bearing. So if I bring it to the starter, it shouldn't be that difficult to understand. So we'll bring all it apart so that maybe after like 5 or 6 starters of similar kind, okay, then you should be able to be confident to answer bearing questions, okay. But still, the video is yesterday's, all the 5 bearing videos will help you if you watch it from the beginning, because I started with the introduction and I built on that. So just be patient. If you watch even last video over like 3 times, you should be able to get it. Okay, but for the sake of people who are working on a lower level, I promise you, I would do a pit starter with maximum of 2 questions. Magnify the diagram like this so that you can see it clearly. Okay, thank you for your help on that, and thank you for your patience on that. Okay, today I would like to introduce you to a topic called Loci, or maybe in real life we'll call it boundaries. Okay, so in the singular is called locus. So 1 point is locus. Okay, plural is loci. Okay, that is how I was taught to say the pronunciation. So if you have any other pronunciation, well, but I know of locus and loci. Okay, now what is it? It's a set of points that fit or satisfy a description. Okay, this is very important. So it is a set of points. Normally they have the same distance. Okay, here is mathematics. Locus have to do with distance from a point. Okay, so for instance, example, the locus of point 3.4 centimeters from O, so that is O. So if I draw a circle all round O, you can see that the radius 3.4 centimeters. So everything on this circle, the boundaries, all the points here will form a loci. Okay, so now the point within are not my loci, is the boundaries, okay, of 3.4 centimeters. So this circle here, the line, okay, or the circumference, okay, that is my loci here. Assuming you live in Lancaster, okay, now we are bringing it to real life, and your scale here is 1 centimeter to 5 kilometers. So Lancaster is here. You've been told 5 centimeter will be 5 kilometers. Okay, so 3 centimeters around Lancaster in actuality is 15 kilometers. So if I draw a circle of 3 centimeters all around Lancaster, okay, then all the towns and cities or villages 3.5 15 kilometers, okay, is 3 centimeters, not 3.5. So okay, 15 kilometers away from Lancaster will be its loci. Okay, so all the towns or cities around or from Lancaster 50 kilometers form a loci. So if you are here, you are not 15 kilometers from Lancaster, because the scale here is 1 centimeter to 5 kilometers. So 3 centimeters will be 15 kilometers. Okay, so if you are within here. You are not in the locus. They want 15 kilometers, which we've scaled down to 3 centimeters using the scale we've been given. So if there is a town or a home or a bar or anything or a school in this 15 kilometers radius, okay, it's kilometers please, then all that will form a locus around Lancaster. Okay, I hope I'm making sense to you. Now, 3. Let's look at another example. This is used a lot in our daily life, but normally we don't even know that they're applying the rule of Lancaster locus. Even the people who apply it, I don't even know they understand that this is what they are doing. Okay, let's look at it. A fish or chips shop or bar serves a small town. Okay, they are allowed free delivery up to 4 miles. So that shop, if you order online or by phone, they will give you free delivery if you live 4 miles away from that shop. Okay, how do they do that? They use the navigator, so they know that if you call and you give them your address, they know that your address is this miles away because they can get it online. Mr. Peter's family lives at a point S, okay, from the shop. Draw a loci around the fish bar and investigate if Mr. Peter's family can have a free delivery or not. Okay, now the scale is 1 centimeter to 1 mile, and free delivery is up to 4 miles. So now here, 1 centimeter to 1 mile, so 4 centimeters will be 4 miles. So I use again my compass, okay, and then I measured it on there, and as you can see, if I zoom in again, it's 4 centimeters, okay, and it's 4 miles. Okay, now all the points on this circle I've drawn, this is the chip shop here. We represent it by C. All this point here is the cut-off boundary and is the loci. Okay, now I've put a lot of X's in between and a bit outside. It says I should investigate because haven't been told where Mr. Peter lives. So in my investigation, if Mr. Peter lives here, if this is his house X, then he can have free delivery. If he lives here, he can have free delivery. If he lives there, he can have free delivery. Even if he lives on the circumference, okay, is 4 miles away from the shop, he can have delivery because they said up to. But even if he lived there, he can't. So he may have to look for another shop that gives that option. Okay. If he lived here, he can't have free delivery. If he lives there, X, he can't. Anything outside the locus or the boundary of the cheap shops 4 mile, nobody will get the free delivery, including Mr. Peters. Okay, so if I'm part of Mr. Peters' family, before I order, I will look and see if I live in the 4 mile radius, which if I'm within this section, because the cutoff or the loci is 4 miles. I hope I'm making sense. Okay, so this is what I've just explained here. Here the loci is all points 4 miles from the shop. If Mr. Peters' home is within 4 miles, they get free delivery. If outside the 4 miles, they do not. Okay, so it's a simple topic, but it's applied in real life a lot. Now let's look at the next example. A GP surgery in a community only registers patients up to 20 miles. Okay, you can understand that because if maybe someone is incapacitated or immobile, they might have to deliver home services. They might have the doctors or the nurses or the health workers might have to go. So if they take somebody 100 miles away, they might be of no use to that patient. So they need patients in the community to register. Okay, now they say use a scale 1 centimeter to 5 miles and draw its boundaries. Okay, so you are going to draw the loci. So they've given you a scale 1 centimeter to 5 miles. So 4 centimeters will be 4 miles. So on paper, you are going to draw 4 centimeters, and your 4 centimeters will be, if that is the surgery, anybody within this area can register in the GP surgery. Okay, if you are outside here, even here, you can't. Okay, this is where you should follow my notes. Okay, if you are there, you can't. Okay, so what I did again was I used the compass. Okay, measured 4 centimeters, and then I used it to draw the circle. Okay, so now as you can see, that is 4 centimeters. Okay, you can see it's 4 centimeters. Okay, so anybody who lives here, but the loci, which is the cutoff point, so all these points around this surgery, all this place, okay, will be the loci. Okay, around. So all these points here will be around. So here again, in real life, they are applying that. They've drawn an invisible boundary. So if you call them and say, I want to register so and so patient, they look at their boundary and see and look at your postcode and see how far away. If you are 18 miles and they have place, they will register you. If you are 15 miles, they will register you. That is if they have space for more patients. But if you are maybe 22 miles, they will say to you, we can't, because maybe if their doctors travel that far, or their health workers travel that far, they might have to pay them more, which might not fit into their budget. So they might ask you or refer you to another surgery within the boundary where you live, so that you can register with them. Okay. Thank you. I hope you are understanding me on that. Now, another one. Draw the boundaries of a town city center in the radius of 45 miles. Okay, so this is a town city center. Okay, now they've given you a scale 1 centimeter to 50 miles. So they can even just ask you a simple question like that. It doesn't involve any calculation apart from saying 3 centimeters is 45 miles. It's okay, because the boundary here of the loci is 45 miles. So you calculate that, and then you use that to draw your boundary. So you measure 3 centimeters with your compass and just draw a circle and say that all these boundaries here, okay, every point on this circle will form a loci from the town city center. So as you can see, my 45 miles, if I use the scale I'm giving, here again will be, if I zoom in, will be 3 centimeters, yeah, okay, which is 45 miles. So this is the town city center, okay, town city center. So everybody, everything here, whether houses, whether schools, if it's another town, they are all loci. Okay, so you are here, you can travel 45 miles south, okay, wherever you get to in the 45 miles. If it's at the beach, that is your loci from the town city center. You can travel north, whatever place you get to. If it's like a city center, that is a loci to this town city center. If you travel that way, west, okay, and if you get here, if it is maybe a fish bar or a community, that is your loci. Any point on this circle here, okay, is your loci or your locus. Singular is locus and plural is locus. All the set of places is loci. One point is locus. Okay. Thank you so much for watching our video today, and I'll see you in the next.